Yes. Okay. So please be noted, the class is now being recorded. Okay. If we have ANSYS installed in your machine, of course, you will see ANSYS 2021, but there are many there. So which one we're going to use is this one, ANSYS APDL product launcher. Okay, you can find it here in the start menu, or in search, you can type APDL, and you can easily find this app there. Okay, there's another one with only Mechanical APDL 2021 R1, and the product launcher is recommended. Okay, let's click this one, because here you can easily specify the folder that you are going to use. Okay, the simulation environment will be ANSYS. License, you can use this mechanical enterprise. Then there are three options there. We basically just need to check the first one, and you can browse any place, any document folder you want to save your document. Okay, I create this one especially for this course, and let the job name. Of course, you can enter any name you prefer, but just easy to remember and to be compared with. Probably I will use 1, 2, 3 because later on I may have different version of analysis. Okay, because in the beginning, as I said, it's easy to make mistakes, and then probably you have to redo the calculation again. Then this helps. Okay, then just run it. Okay, then here we have, this is the interface, and besides we still have this output window. Okay, this is also important in some sense. It says we are opening this ANSYS student version 2021, and there's some default setting there, not very critical to us. Okay, then if you do some operations there, probably some information will be shown here in this output window. Okay, now if we focus on the interface, we call it sometimes for short GUI. So this is a graphic user interface, and we have the main window. The background is black, and of course I think you can change somehow the background color or the font or the size of these words. Okay, and so let's open this folder. This is the folder that I used to save the data. Okay, it was empty, of course, in the beginning before you starting ANSYS. But now there are several documents automatically generated. We have this log document. I believe it's not many information there. Let's start to open it. Okay, it says here in this time in the morning, and we start ANSYS, and there are some default setting. In the slides yesterday, I said before, most of these commands starting with this slash, they are not so critical. Okay, just close it. And we have this error document. I believe there's nothing there because there's no error or warning recorded. We didn't start any operation yet. And we have this output. This will be the same as the output window. If you remember, we have this output window. So this information will be there. This is like somehow a report, okay, saying yeah, we're opening ANSYS, and yeah, with not many information at this moment. Okay, but later on, you see we don't have a database .db file, but if we go to the main interface, even we didn't do anything, we don't have anything in the for the model. We can.
Sorry, I have a question.
Yes, please.
I kind of fell through when. Where do I press after you type a job name to get into where you are now?
You mean here?
I had something wrong with my computer. I don't see the run under. Oh, sorry. Thanks.
Okay, so it's probably a size of this this dialog window. Okay, it's at the bottom.
Yeah, I see it now. Thank you.
Okay. Yeah, it's good. You can stop me anytime during this lecture and asking questions. Or alternatively, you can type your question if there are many words and it's complicated. You think it's better to type in words, so you can use the chat function, okay, of the Zoom meeting. I was trying to say the database we have here, SafeDB. So if we click here, even we don't have nothing there. Okay, I did it. Then let's go back to the folder. Is this one? We have now this document 1.db. Of course, this is the file name. If you have another name like pipe analysis, it could be a long name. There's no problem. I think there's a limit, but with like probably so many letters available. Okay, this is 1.db, and the size is quite small because basically we don't have anything there. Okay, the size could differ from case to case. Could be several megabytes or even like 100. Depends on how large is your model. Okay, then on the left-hand side, we have the main menu. Okay, we have several options to use: preprocessor, solution, and general post-processor. These three are the main functions that we're going to use. Okay. And I would like to call your attention, there's no undo function there in ANSYS, unfortunately. Then if you did anything wrong, then it's difficult. You cannot just do a simple undo. So you have to, there are different options. One is to completely start from the beginning and trying to remember what are correct and complete to reproduce these correct steps and try what was wrong, try to correct it. So that's why I recommend to use a macro file. Okay, a macro file you can create here, start a new Word document. We call it macro1, for instance. And of course, you can keep the extension as .txt, or you can change it to a Mac. Okay, we open it here, and later on, probably we can continue put the comments here. Okay, I will open it with just the notepad. Then we can see, we can open the log file as well. Okay, what we did before, it's just list save. Okay, this is the only operation we did in the interface. So it records this operation there as a command of save. So this is an APDL sentence. Okay, just a simple save. By the way, if you open this log file and you do more things there in ANSYS, this one won't be updated. You have to close it and open it again. Okay, for update. And of course, we start always with the preprocessor, okay, the modeling. The first option, element type. If you have the number 2 finite element analysis number 2 PDF file with you, we are referring now to the page 24. Let me see, probably I can open it as well here. Okay, we're referring now because today we don't do a complete analysis. Okay, I think we focus more on the modeling part, and I would like just to show you how to start ANSYS and how to use the basic operations. So it's like a practice. We start with the element type. If we can see here, we have this element, shell element and solid element. Okay, this is in the number 2 PDF, page 22 to 23. So there we can, before it was like this, you can click the plus icon and then element type. Okay, to add, edit, or delete, they are in the same function. So it was non-defined in the beginning, and we have to, of course, add one element type. So let's say we do share and shell with 181 or solid with 18586. You may start to ask if I use a little bit different element type, what will happen for a result? Of course, the result will be different. It depends on how many nodes you have for each element. Okay. So there are many uncertainties, let's say, during the finite element analysis. So a sensitivity analysis, or we say parametric analysis, could be performed before you determine the final, you make the final decision. Okay, you can try with both element type to see the result will be quite similar or largely different. So here, let's say the shell 181. Okay, the default number is number 1. So we can click here, OK. There is a difference between OK and apply. They both execute the operation you want to do. But for OK, it will close this window. Okay. For apply, I think it won't close it. And if you are going to do consecutively many operations with the same type, for instance, here, the element type, if you have 1, 2, 3, 4, okay, instead of click OK and open to add again, you can just click apply and then change to another one. Okay, so I will show you both OK and apply. So let's do OK first. I click it and there's nothing. This one disappeared, and in this element types, you have this type number 1, will share 181. Okay, and because I want to show you exactly how it works between GOI and APDL, so we will do it slowly. Let's go back to this folder you have. Let's open this log file again. So let's see what we have. If you remember, we stopped here after save. Yes. Now we have this /prop7. This is to start the preprocessor. So this one is quite important. What we can do, we can copy it, and in a macro file, we can paste it here. Okay. This will be the first commands that we enter. And also I mentioned all these words or sentences following by this exclamation mark will be not executed by a program. So you can use it to take notes. Okay, you can say SPS task analysis or finite element analysis pipe try one, for instance, anything you like to record it. Just later on, if you want to recall what was happening there, so it will help. Then here in this log file, the next one you have this ET1. ET is for element type, okay, number 1 and shell. So this is the definition of this element. We can copy it because we want to use it as a macro file, APDL. So we paste it there. So you have these two. Okay, then here I will try to show you what will be the difference between OK and apply. Okay, now if we want to have another element type number 281, okay, we can click here apply. Okay, you see in the element type it has one more element type, and this window is still there, so it will be easier for you to do another one if you want to add number 3. Okay, it's there, and still this window is there for your use. Of course, you may say the difference is minor, then it doesn't matter if I click OK and add one more again, of course. But this is the difference. So for not only in this element type definition, in most of the operations, you have this OK and apply options. So pay attention to these options. The apply may help you if you want to do more in the same type of analysis. Okay, and there is one more thing. Sometimes if you open too many windows in this ANSYS, you may try to miss some of them. How to say? And there is an option of to raise the hidden windows. Okay. For instance, if we have these material models, and then later on you want to click somewhere, and then you see now the main menu is in gray. This means they are not functioning. And you may start to be worried, what do I can do here? Because you cannot click anything there and neither type anything there. That is because you have a hidden window somewhere. So you can click this one, okay, and this will show up. Then you have to do something here, or at least you have to close it. Then you are able to do the further operations in other menus. Okay. Then let's see, we can clear and start new, because I input element type 1, 2, 3, 4, which is not the case we want. So okay, here there will be information to verify if you want to click to clear everything. This means you are going to delete everything you had created and returns to the beginning. There's nothing. Yes. Okay. So now there's nothing there. What I want to show you is we can use these two commands. We can now copy it, and here in this command prompt we can paste. Okay. Not only one line works there. You can have multiple lines. There's no problem, and just don't change any format of there. Okay, there are 2 lines there, and you can just in the keyboard enter. Okay, there's something happen. Even you don't see anything in the main screen. But if you go to the preprocessor element type add, you will see there's already number 1 element type defined there. Okay, for those who are more familiar with ANSYS and had experience, of course, this is quite simple. But since we have many students that are new to ANSYS, so I would like to, I think it's better to explain this in detail. Okay, now if we go to the log file again, this was the old one. We have to turn it off, close it.
Sorry?
Yes, please.
So it's just copying ET5 shell, whatever, the file says, copying and put it in the command line.
Yes.
Then enter.
Yes. Of course, if you are more familiar with this one, you can try to enter it by yourself, like ET, I would say number 2, and I will say 186. You can type it like this and enter, and the program will execute that for you. So if you check here again, you will have 2, and this 186 is with solid. Okay, type number 2.
Because I'm getting a warning that the command will be ignored because the ET is not recognized and so on.
But that is a problem. I don't know if you can share your screen from your side. I just want to check what is happening. It could be a problem with the format, or probably you don't, I guess you don't have this pre-process. Yeah, now I'm sure this is the problem, because you have to start the pre-processor in the beginning. So these two has to work together. You have to open this one first. Otherwise, there will be a warning to say ET is not a recognized command for preprocessor or for things like this. Yes? What I guess is you did this line, but not this line. So that warning appears.
Yep, this works. Thanks.
Okay. And I just showed you how to type there, and we can say ET delete, okay, delete, but not complete delete, it's just DELE. And you can say type 2 and enter. Okay, there's nothing appear in this main menu, but if you check there, you have only the type number 1, because we deleted type number 2 by this ET delete. Okay, then we can access the ANSYS help here. You may say how I can know how to use this ET or ET delete. That is from this command reference. So you have to, if you want to know what is ET, so you can go here. ET is this one. Okay, used to define a local element type from the element laboratory. So there's a specific format. You have to follow this one. ET, the number of the type number, number 1, 2, 3, and the name. Of course, the name, here if you type ET1 shell 181, and this is the same as you ignore this shell, because 181 is especially for shell. I mean, we don't have solid and shell with the same type number. So the 181 is only a shell 181, so they both work. Okay, and here in this ANSYS help, you can check many things there. And of course, there's some options there, but sometimes you can use the default value if they're not quite critical. And also here, if you click, if you type here ET, I think, yes, this format shows up there already. So we see the next one, you have to put a comma and then the number of the type and the E name, the name of the element. Okay, ET, delete. So you can delete not only one, you can delete many in a time. For instance, let's say 100, okay? And there's another one with INC, is number of increments. If we don't put anything there, the default one is 1. This one means we delete the element type from number 1 to number 100. We delete all of them. Okay, if we put this increment as a number 2, this means we delete element 1, but not 2. Again, 3. Next one is 3. 1, 3, 5, 7, 9 like this. If this increment is number 3, so this means 1 and 4 plus 3, 7 plus 3, 10 like this. Okay. So there are many comments like this. You can have two numbers, the starting number and the ending number, and with the increment in between. Okay. So if we now open the log file, I believe there are many things there. Okay, after we save our database, we have this preprocessor. We need to use this function before all the modeling part. And we have used these 4 element types. And finish, because I was clearing everything there. So it shows a new start at this time. And now I just use element type number 1 and 2, but then I delete type number 2. So sometimes you do some delete, and then you may, just for simplicity, you may copy paste a lot of lines in the log file and paste there. Of course, it's okay because it will create and delete, so it's equivalent. But if you pay attention to it, these 2 lines are not that like automatically cancelled, so you don't need to paste them there. Okay. Go back to this PDF. Now we have this shell element installed. Of course, later on we will show what is the case for solid. Now let's start with the shell. And we have to now define what is the material. Okay. Then this is, let's close this one element type. Let's go to material props. And we can do it in material models here. Just a single click, this one will show up. It was nothing there. So we have to go to structural, linear, elastic, isotropic. And this is the Young's modulus and the Poisson ratio. Poisson ratio is normally 0.3. The Young's modulus, because we don't have any unit in ANSYS, so you have to do this in the preliminary decision. What kind of unit system is used? The SI unit, of course, they are recommended, meaning meters and the Pascal. Then if it's in Pascal, we have to say this is 2E11, okay? The scientific notation is recognized in ANSYS, so you don't need to put so many zeros. And this small e and capital E, it doesn't matter, they both work. And of course, sometimes it varies like 2.07 or 2.1 for different type of steel, okay? Our pipe, they are made in steel. So of course, if you have dependent properties, you can make a graph there, but now it doesn't make sense because we have everything. We have just a horizontal line. This is a constant value. It's not time or temperature dependent. So, okay. Now let's go to the log file. We have this one. So let's just copy paste everything here. Of course, these 2 lines are the definition of Young's modulus and the Poisson ratio. But sometimes this one is necessary. To be honest, I'm not sure if this line can be deleted. But in your case, you can have a try. You can try to put, for instance, this one here. And there is a command for clear. We normally put finish and clear there. Then I can copy paste this one there. Okay, now it's in gray because there's some hidden windows, and we have to close it. And I paste everything there. Okay, it starts with the from the finish clear, but doesn't matter, just enter. Then it will ask you, are you sure you want to clear everything? Because sometimes you did it by mistake. Okay, then let's check if we have these two. Yes, we have them there. And I will try, so this means this one is not important. Let's see if I omit this one. It will give any warning or not. This one, type, paste, enter. Okay. No, it's not defined. The mp data command is ignored. So if we check here, there's no such ANSYS modelers and Poisson ratio defined, which tells us this command is important, so we cannot ignore it. Okay, this is about the temperature of 0 degrees C or 0 Kelvin. We don't have temperature dependent properties at our task, but still you have to say this is at what temperature. Okay, it doesn't matter if it's 0 or you may say it's not 0, it should be 20 degrees C in real life, but it doesn't matter. Okay, with this we have this Young's modulus at Poisson ratio defined it. Then a more complicated task is this one, the stress strain value. Okay, I'm not sure if we can just use these values there. Because we have to find in a paper what is the stress strain curve. This is a little bit complicated part, but I will show you how to do this in ANSYS first. So there you have, by the way, we just used the wrong macro, so that one was ignored and the element is not, the property is not there. So we have to paste this Young's modulus and with these 3 lines together there. Okay, now they're there. So instead of linear, we have non-linear properties still in elastic, and multilinear, we can use this one. And we will have the first value of stress strain. And of course, you can add, not add temperature because we have, we don't have temperature dependent properties. So we just, you can add point, you can add several more points. Okay, what I can show you there, let's say if we have EX. Okay, by the way, I will start to tell you about these parameters here, because later on I want to show, I want to use these parameters. Instead of values, I want to use the name. So you can say EX equals 2, what was the value I was using? 2.1 E11. Okay, this is I typed and accept there. Poisson ratio, Poisson ratio, PR, I will say this is equal to 0.3. Accept there, okay. And then I can close it. Why I did that? Because I want to type here EX and this one will be, you see, we have this value there. So let's say 0.001. This is artificial, okay? It's not a real case. So times. By the way, the operations works in ANSYS. This means if you do a plus, a minus, a multiplication, division, ANSYS will do that calculation for you. Okay, if I click here, okay, let's see if it's recognized or not. Yes, so make a graph. There's no table to plot. So probably we have to add the second point, which is a little bit larger. I would say it reaches 2.2 E8. Okay. Let's check in the log file what we have there. So this is to set. Okay, we have these two there. So it's possibly we copy paste here in this macro file. Okay. And we can say this is parameters definition predefined. Of course, you can make more to make it more clear. And this is the modeling. So here, instead of this one, we can put an EX and a PR here. Instead of the real value, we can put the predefined parameter there. Then here, we are going to create this TP meta, MELA. Let's see what okay, then I would like to start from beginning. I will copy paste this one. In ANSYS, paste. Since we have a click in a clear command in the beginning, so I don't need to in the file clear again. So I can just enter here. Okay, so it gives us the element type. This one for the material, it has the linear one, and for the non-linear one, we are going to do it again. Elastic, multilinear. Okay, we need to type what is a strand and what is stress. Let's try to see if we could use the data here. It's 08741 with 3 zeros. And for stress, that is E8. And at the second point with E8. Okay, I will have these two data, but I cannot plot this one. Has no data to plot. So let's check this meta. Minus E123 TBPT. So here they are doing a temperature dependent one. So at a temperature of 70, they have this definition. And for this temperature of 200, they have this definition. TB field, I think we don't need it. So let me see what we have here. So this TB mela. So this mela and the mela, I think there's an S here. So if I copy this one and paste in the macro, and I will include an S here. The capital and small letters doesn't matter in APDL because I can put capital. So I will try to delete those 2 points. I will delete it. Okay, and in ANSYS, I will type in APDL, paste, to see if I can have the same 2 points there with the graph. But still the plot is not functioning. The meta table has no data to plot, TB plot. I don't know if this is matters with number of points. So I will go to the output. This warning, oh, let's go to the error, could be here. There are always warning here. Let me try to just search for it. Basically, to my knowledge, I think this doesn't matter because you have the stress strength graph there. Okay, this is not the case. So I will try to do this one. I will paste it in the macro to see what is the difference. 1, 2, 3. Temp view temp, let's say 0. We'll copy this one, try to see the example given in ANSYS help. We'll go here, okay, and I will delete this multilinear. Right click here, delete. Okay. Then in ANSYS, where is it? I will enter, I will paste these parts there. Paste. So there are these 3 points. But again, it doesn't work. Okay, then I think I will stop trying to plot it. But instead, just I will call your attention. You need to have correct values here of the stress strain curve. Okay. You can check, of course, in the reference paper. The curve will be more or less like this. Okay, as you could see in the reference paper. At the end of the slides, there are papers. Not at the end of slide. In this, at the end of this part 4, okay. For instance, if we are referring to NATO 2007 or 2005 paper, excuse me. So here in this paper for the figures, this is the one I was mentioning. So there are many programs can be used like AutoCAD or Rhino or TechPlot. Probably you can create some, you can paste this image and trying to simulate with several key points there. Okay, then you can have the coordinates of these key points. Then this is like say 10 or 12 points. You can put the XY coordinate here, okay, as the points. So we can click OK there. Let's check in the arrow file if this is acceptable. I think it only says the plot is not functioning, okay, but before that there's no many. So the temperature table is not defined. This comes from where? This was in the macro file before I was trying to ignore this comment. So it said it gives a warning to say the temperature is not defined. So we have to define a temperature. Even this is not the main consideration. Okay, so probably we'll do like this part. And of course you have to include more points than multilinear part. Then let's check what's going on there after the material nonlinear curve. We will start the modeling part now, and we can create a circle. Okay, so let's do it firstly in GUI, and then I will show you the APDL. So now, finally, before this element and material, we can go to the modeling part. To create, we have to create many things. And align as an arc, because we are using a shell element. So do remember, in 2D, we will have just a circle. Then in 3D, we will extrude this circle or this line into areas. So there are many options to do an arc. We will do this by center and radius, I believe. Yes. So here we can click somewhere, okay, and you can left click and hold your mouse to become bigger or less. This is the radius. Or you can type. You can type there. Okay. What is the global Cartesian if you say I want to the center to be 0, 0 and 0. Apply, and then that will be the radius. So let's say the radius is, it depends on the diameter, of course, of your pipe. So I will give just an artificial value, let's say 1 meter, and okay. Then here, if you need a full circle, the default value of degrees is 360. And of course, if you change it to 180, this will be a semicircle. Okay, we need a full circle. And number of segments, I mentioned that before, it determines how many lines you will have there. If you say this is 1, and okay, so we are having now 4 lines. If we can list here lines, okay, we have 1, 2, 3. Yeah, I'm sorry, there are 3 lines there. Okay, normally the program, even I did 1, but it divided into 3 parts because 1 is too small value. Okay, so in the port control, you can show the numbering. You can turn on the number of lines. Okay, then you will see L1, L2, and L3 there. They're in different color, and there are 3 lines there. They're all is in this XY. Let's say Z equals 0 in this plane. If you can turn on the dynamic model mode, you can use your right mouse button to rotate it. Okay, so this is in Z direction. Or if you click this was a front value, front view. If you use a left or right view, they will look like this. Okay, so the Z is 0 there, and you have the XY plot of this line. And there are some key points already generated. If we turn on a number of key points, you will see here there are 1, 2, and 3 key points, because by connecting 2 key points, you create a line. So this is what I said, the bottom up or top down. So this is like a top down because we create a line instead of key points. So we can create a line and it will automatically generate key points. Alternatively, we can create the point in a specific location by the coordinate system, the coordinates, and then trying to connect them. Okay. Do a straight line is easier to do that, but with a circle, it's better you can create a circle directly. Then, because I made a small part of line segment, if you remember, so now I want to delete this one. instead of create, there is a function of delete. Okay, I will delete lines. There are two options you can see here, lines only and line and below. What will be different? The difference. If you click here, line only, then this line 1, 2, 3 will be deleted. But these three key points, they will be there. But if we click line and below, this means these three key points, they are associated to this line, so they will be deleted as well. You can type the number like 1, 3. Okay, this is meaning 1, 2, 3. And if you don't put the increment, the default one will be 1. So they are 1, 2, 3. If you say 1, 3, 2, this means 1 and 3. 1 plus 2 is 3. So the 2 will be there, not to be deleted. Or instead, we can click here, pick all. Okay, so all the lines and key points, they are deleted. If you list the lines, there's nothing there, no lines to list. And if you list the key points also, there are nothing there. There's nothing there. So now we can create the lines, the arc, the circle again. Okay, the center will be 0, 0, 0. Okay, and the radius is 1 with 360. And now I want a 10 number of lines in arc. And okay, so now we see we have 10 lines there. Okay, so I didn't check the default number because according to the experience we just had, the one line is not working, so it gives me 3 lines. So probably 3 is the minimum requirement. So you can put any value more than 3. If you list now the lines, they are 10 there. Okay. And the first line is made of key points 1, 2, and 2, 3, 3, 4, etc. 10, 1. Okay. It has the length. If you calculate the pi d, the circumference of the circle, divided by 10, it will be this value. I didn't do that, but I believe it has to be. Since we don't have more element node defined, so there's nothing there. So these are the lines and key points. Then, okay, so let's go to the log file. Let's see what we have there. Okay, there are many. So you have to understand what is more important and what is not. So starting from here, I think we create this circle and I list all the lines. Then there are some changing different view. If you remember, I tried to rotate the 3D model. So these ones are not necessary. And I delete this line, arrow, the line, delete, okay. And then I make a new circle with this one. So in some sense, the log file are different as APDL, because if you copy paste from log file, they will be like this. Okay, because there are some options that are not executed by the program. For this one, it's like a peak there. Okay, so it's not like a full how to say, the formal APDL, but still it can be read. Let's say if we copy paste everything there. Let's say if they will do it. Okay, they start to generate this one. And there's no number of lines appear because I didn't copy paste. I think this one's is to turn on the number of lines and key points is this one. Okay. So if we copy paste these two, and of course they are not critical. If you paste these two lines, P number of key point and line, you can use, I believe, 0 and 1 to represent on, off and on. 0 is off, 1 is on. So if I enter here, and we have to do a replot. Okay, you have to click there again. This number of lines and key points are shown. So actually, you can click here to check what are all these APDL you executed. For instance, you can check the last one. Okay, now you change the key from 1 to 0. Okay, and you can type a replot. This is the same function as you click there on the main menu. Okay, you see now the number of lines are not shown. Okay, and you can use the page up, page down, or up and down button to switch between different commands that you had already imported. So for key points, I want to turn it off. Okay, just a 0 there, enter, and then replot. Okay, then that one disappear. Okay, so we were here. These ones are the create of a circle, but as I mentioned, it's not quite formal. So we can check what is the formal one. It will be the circle and the center point and the radius. So let's see if we delete this line. Delete line and below, pick all. Okay, it's not there. So I have to create a circle. The point will be 0, 0, 0. And the radius is 1. P-axis, no P0, no arc. Arc is 360. I believe if I put 360 or I just put a comma, it will be the same because that's the default value. Number of segment is a 10. Key point 0 is not defined. So it's a matter of how we define this center. So probably in this case, I have to create the key point first. 1, 0, 0, 0 here. And then to do the circle value, I can put number 1 there, radius 1, p-axis no by default, p0 by default, arc by default, and number of segment 10. Okay, then it's there. But now I create a key point number 1 at the center just for reference. So these two APDL that I used, you can do it in a macro file. Okay, this is looks more professional, let's say. But actually, these two they have the same function, so you can either use one of it. Okay, the new users they use to copy paste these ones, but there's no problem. Okay, but it's better like what I did, just in every step. Later on, you have to check the macro file. Maybe some useful comments in the useful lines in the log file is ignored, so there's a warning or error. So you have to check this carefully. Okay, just to make sure, I will copy everything here and paste it there. Yes. Okay. List number of lines 1 to 10. Okay. And of course, depends on your preference. Again, I want to emphasize everything I did today is just an example. It doesn't relate it directly to our project work. Okay. So you may use a 20, of course, line segment for a circle. It doesn't matter. That depends on how fine later on you can mesh, you can create the elements. So now if we see here, we have, I think quite a lot, maybe 50 lines. So if I change this to 50, again, it's not possible. Like I want to cancel this 10 segment and input a 50 there. So let's, in this case, the advantage of APDL is shown. Okay, we have now, if we turn on P number and line, if we put key 1 to show and replot, okay, you see we have 50 lines there, starting from 1 and with anti-clockwise direction until line 50 here. Okay, for next step, we're going to make areas to make it 3D. So what we can do is from here, preprocessor, operate, instead of, we have create and delete, of course, and copy here. And now we are going to do operate and extrude lines along axis and along lines. Let me see, probably we need a reference line. Let's say along axis, we have to pick all lines. This is the first step, which lines we are going to extrude. So we need 1 to 50, all of these lines at this moment. So we use pick all. And we have to specify what is the axis. I don't know if functions with Z. Or as I understood, we have to create a line. So let me see how many key points we have there. We have 1 and 2. Let's scroll down to the end, 51. Okay, so I will give a key point number 2. Sorry, not possible to be number 2. So 52 at least, or you can make it 100. Just not to overlapping the existing values. I will say I want the length of the pipe to be 10, let's say. So it will be 0, 0, and 10. Okay. If I click here, fit view, see, I have another one there. So now I want to connect this number 1 and 100 to be a straight line. So I use this command. Okay. Then this line number 51 is a reference line. So we can extrude the lines along lines. But now it's not possible to pick all because we have to exclude this line number 51. So let's say 1 to 50. Okay, and then here you can select, by the way, if you click here, you're able to, it's possible you can select those lines if you plot the lines, okay? You can select them like so many, one by one, but you have to do that 50 times. So instead, but actually there is also a better way. Later on I will say, you can select this, the pick all always means pick everything that has been selected. It's not pick all the components, like all the lines existing in the model. No. So if we say we select the lines by number of pick, okay, and then if you say 1 to 50, okay, so if you replot, sorry, I have just 1 and 50. So 1, 50, sorry, because the default one is list of items. We have to switch it to minimum, maximum, and increment. So 150 should work. Okay, so we select these 50 lines. Then we can click along lines. Now we can do this by pick all. So here the pick all means 1 to 50. All the selected lines, not including the 51. Then this one, there are two ways. Either we type here 51, okay, I believe it will work. Then if we plot area, no, doesn't work. Plot, so along lines, pick all. Then we have to try to select everything. Then replot to see if now we have 51 there. Now we can type here 51, or we can click it there. Okay, you see I had difficulty by selecting. I don't know if you noticed that. I was trying to click here 51, but after I click, here it tells me I chose line number 28. 28. It was here. I mean, it's small here, but actually it has a little bit difference there. If we zoom in here, okay, this one has been selected. What is the reason for it? Because we don't have this full of this line number 51 in the screen. So I have to use this fit view. Okay, in this case, I can't. I was trying to select line 51. So what we can do? I want to rotate this model. Okay. So there's a function of a box. You can use a box to make a rectangle. Okay, so it says all is counts 50. So all these lines are being selected. Okay, and now we can click this 51 and okay. Then now we have this 3D shape. If we plot the area, okay, they're there. Of course, the number of lines is a little bit annoying, so we can turn that off. It's here, 0. Okay, now we have this 3D shape. Of course, if we list the number of areas, there are 50, I believe, because we have in 2D 50 lines. Now there are 50 areas. So we can go to the log file. Because we tried many things, I just want to show you different operations. But here, actually, the important one is just this one, a jog. But probably the previous 3 lines, they are also important. because it says how we select these nodes. So let's copy paste it here. Or we can use this one to say it's more formal if we select lines and by the number 1, 2, 3, 4, 5 and starting from 1 to 50. And then in this case we can put all here 1, 2, 3, 4, 5, 6 and 51. Okay, then I will try both ways to see if they work. I will just check the first one. Okay, copy paste everything. Paste here, enter. Because 51 is not allowed. So this somehow we have to select this 51. Or let me try the second way maybe. But instead of delete these ones, I will just put an exclamation mark before it, okay, just to ignore this one. Because later on, if you want to reuse it, you still have them there. So I will try to see if this one works. Paste. So what I can do here, we can check here. This one is I can do a save because now we have no area, no. And if we plot the lines, they are okay. I understand what was happening because I did a creation of this line number 51, but I forgot to put it there in a macro file. That's the problem. So I have to have a new key point 0, 0, 10, and I need to connect this 1 and 100 because this is a line number 51. So now it should work. Paste. The air cell is not okay. Okay, it's functioning, but still there's a warning to say air cell is not working. Air cell is this one. So probably I have a problem with number of 1, 2, 3, 4, 5 common air cell. 1, 2, 1, 2, 3, 4. Yeah, I just need 4, and then it will be 1 to 50. It will be like this, and there will be no warning. Want to check it again. Paste, enter. Okay. Now we have this only a number of. We see only key points, but then you can try to plot different components. Lines, you have these lines. They're not all fit in the screen, so you can click this fit view. Okay, looks better. Then you can plot areas. You can of course, in the Pro Control, you can turn off the numbering of different components. Okay, that 1 to 50. This number locates at the center of each line. We have a very large aspect ratio, okay, because the length is a 10. So up to now we stopped here at this generated areas by dragging lines. And let me see if we have time to do a quick mesh. Okay. So it's here in the, after modeling, there's a meshing. We can click here, this mesh tool. There are so many ways to do this one. For instance, you can turn on the smart size. Okay. And this is between fine to coarse. Of course, this one is the finest, and this one is the coarsest. So let's try start from the middle one, and then trying to mesh all these areas mapped. Okay, you can try freely and mapped. I think for free, maybe there are some irregular. So let's try if this mapped works, and mesh. Smelling sizing is so probably we have to use free and pick all. Okay, so with this we have done without any specification of, you don't know what is the element size and what is the number of divisions actually, but this is one way. Okay, it's like you give the program the permission to do the mesh for you. And of course we can have different type of, if you can do a very fine mesh. Let's see, I think we have enough number of elements. If we mesh it again to pick all, this means to mesh all the areas. Then it will ask you to confirm if you want to remesh it. This means to overwrite the existing mesh. And yes, okay. Okay, with this we have a relatively finer mesh with smaller element size, meaning, and you can list the elements. Okay, how many elements on Earth we have now? At this moment, we have 6,500. So they're a small number actually, because we have, instead of 6,000, we have 128,000. This is the maximum available for the student version. Okay, see that already. I think this is a fine mesh. And instead of the smart sizing, we can specify, we can choose the line. If we plot lines, oops, plot, and we can select each one of this line. Or if we move it to list view, fit, we can use a box to select all these lines in the middle. Yes, count 50, okay. Then we can give it an element size or number of the division. This is more under control, okay? You will know what is the element size you are using. But the smart sizing is okay. It's possible to be used in our mesh, in our project work. Just later on, you have to check if it looks okay. And that's it. Okay. Now, even with this free mesh, it gives us, if we plot the elements, I think it looks nice. Okay, so this is one possible way of meshing. Okay, for the tutorial in ANSYS today, I think we can stop here. And of course, before leaving, you can feel free to leave, but you can stay if you have any question to ask me. I will stop the recording.